Hello everyone. Today I will be presenting on the topic hydrogen fuel cell vehicles, technology and infrastructure from basic principles to 2025 real world applications. So, my presentation will cover four main topics. First, the basic principles of how hydrogen fuel cells work. Second, the recent advances in this technology up to 2025. Third, real world applications, meaning the actual vehicles and models available today. And finally, the infrastructure development and refueling networks and expansion plans around the world. So, hydrogen fuel cells work through an electrochemical process. Pure hydrogen gas enters the anode side of the fuel cell. Here it splits into protons and electrons. The protons pass through a membrane, while the electrons travel through an external circuit, creating an electrical current. This electricity powers the motor, and when hydrogen combines with oxygen at the cathode, the only byproduct is water vapor. So essentially, fuel cells generate clean electricity with zero harmful emissions. To understand the full operation, hydrogen is stored in high pressure tanks to ensure safety and enough driving range inside the fuel cell. Hydrogen splits into protons and electrons at the anode. At the cathode, oxygen from the air reacts with these protons and electrons to form water vapor. The electricity produced runs the motor, while extra energy is stored in a small battery to help during acceleration and regenerative braking. This makes fuel cells not only clean but also efficient in real time driving conditions. So moving on to the next slide. Recent years have seen major improvements. For example, researchers at UCLA developed a new fuel cell designed using a graphene protective layer, which extends the lifespan beyond 200,000 hours. Also, system efficiency has increased dramatically. Fuel cells in 2025 can achieve about 65% efficiency compared to just 45% in 2015. This shows how quickly the technology is maturing and becoming more practical. So now let's look at some real world vehicles available in 2025. The Toyota Mirai offers a 400-mile range, zero emissions, and can be refueled in just 5 minutes, making it practical choice for drives. The Hyundai Accent truck is designed for heavy duty transport, already in operation in Switzerland, proving that hydrogen works well for freight solutions. And the Honda CRV FCEV is the first plug-in hydrogen fuel cell vehicle in America. It combines hydrogen fueling with plug-in charging, giving drivers flexibility. These examples show that hydrogen vehicles are no longer just concepts but real-world products on the market. So the global infrastructure growth. Of course, vehicles need refueling infrastructure. Globally, hydrogen refueling stations have grown by 30% year over year, with over 1,200 stations now in operation. China leads with more than 540 stations, followed by Japan and California. In fact, California alone has more than 60 retail stations serving over 15,000 fuel cell vehicles. So we are seeing real progress in building the ecosystem needed for hydrogen transport. So, talking about the methods, hydrogen can be produced in several ways. The cleanest is renewable electrolysis, where wind or solar energy is used to split water into hydrogen and oxygen. This produces zero emissions. Another common method is steam methane reforming, which uses natural gas. With carbon capture technology, it can become much cleaner. Finally, hydrogen can also come from industrial byproducts such as in petroleum refining or chlorine production. These methods show how hydrogen fits into both renewable energy systems and existing industries. So HFCV Market Analysis 2025, like any technology, hydrogen vehicles have strengths and weaknesses. Their strengths include zero emission, fast 5-minute refueling, long ranges above 400 miles, and quiet operation. The weaknesses are high vehicle cost, limited fueling stations, and production challenges. But there are also great opportunities such as government incentives, infrastructure expansion, and adoption in commercial fleets. On the other hand, threats include competition from battery electric vehicles, the need for heavy infrastructure investment, and safety concerns. So, while the future is promising, challenges still remain. So, talking about the future outlook and applications, Looking ahead, hydrogen fuel cells will expand beyond cars and trucks. In marine transport, ferries and cargo ships are beginning to run on hydrogen, with the first ferries already operational in 2025. In aviation, regional aircraft and airport vehicles are starting to adopt hydrogen, with short haul hydrogen flights expected by 2030. And in rail transport, hydrogen powertrains are already running in Europe on non electrified roads, reducing costs and emissions. So, the potential applications are very broad: land, sea, and air. So, thank you. To conclude, I would say that hydrogen fuel cell vehicles offer a clean, efficient, and practical alternatives to fossil fuels. With advances in technology and global infrastructure, we are moving closer to a future of zero emission transport across multiple industries. Thank you for listening.